Hello. On this video we'll be looking at calculus differentiation by first principle. We will understand what differentiation is, as well as what do we mean by differentiation by first principle. Now, without any waste of time, we will go straight to the origin of this. So let's go quickly recap on straight line. Let's recap on straight line. What did I do now? What did I do? Okay. Let's quickly recap on straight line. There, we have a coordinate system, so we can quickly just draw a straight line using a ruler. We'll have that. Okay, so then now we know that our axis, we have x-axis and the y-axis in that form. So we know that the gradient of a straight line y equals to mx plus c will be given by 2 points, which is x1 as well as x2. x1 will correspond to y1 and x2 will correspond to y2. So now finding a gradient between 2 points means we're talking about average gradient. Okay, so it's a gradient between 2 points, which equals to change in y all over a change in x, of which we know that this is the same as change in y over change in x, and we know that from here to there we have a change in x, and from here from the y1 to y2, which will be change in y. Okay, so then now this gives us the average gradient, which is equals to y2 minus y1 all over x2 minus x1. So this is pretty straightforward. So that's our gradient m between a and b. So what happens when you now have a hyperbola, or you now have for instance a parabola? You'll be confronted with the same situation. You'll still need to draw. Let's just have a graph from this point. Let's just have it from this point going like this. Okay, so we still have our x, we still have our y accordingly. Okay, and then remember this graph goes like that. Okay, but then in this case I'm interested in the right hand side. So then now we'll still have our x, but then going further we can add h, and then we call this point x plus h. Okay, so which means the distance between x and x plus h will be, let's guess, h. Okay, so if this is our f of x, then substituting x in place of x will give us f of x. So the corresponding y value here will be f of x, and the corresponding y value here will be f of x plus h. Okay, so we can make up a gradient from there. So the average gradient between the 2 points will be f of x plus h, which is our y2, minus the initial, which is f of x, all over h, which is our change of x. Remember here the distance between the two, so it will be change of x. Right, So this is point A, this is point B. So the question is now, the point A does not give you the gradient along this line. It actually it doesn't give you the point on the curve along this line or this curve. It actually approximate between the 2 points. Use the two values and find the average between the two. So what happens when you actually need, what does it give you? It actually gives you the gradient of a straight line, which is imaginary when you look at it, of this kind. Gives you something of this kind. Okay, so then now the question is, what then does that mean? So it gives you the point between the two, imaginary, not exactly on the curve. Okay, so then now it means that if this is the case, then it means this is what you have. You have this triangle instead, which is pretty much the same as the one for straight line. So that's what the average gradient does. So then now how do we then find the gradient at point A and at point B? We can choose. Let's just work with point A. So which means now you will have to take a limit. Now we reduce h. We take a limit and take the limit of h tends to 0. Now you remove the distance between the 2 points. You actually take the x back to the x plus 1 back to x. So which means now if we approach it from the right going to this point, it means now the graph from here will decrease from that point to A. Okay, so then which means now if that's the case, it means if you only need to take a limit of f of x, which means now you'll take the limit of f of x plus h minus f of x all over h when h approaches 0. So this will be your gradient at the point. So a limit of a certain function gives us the gradient at that point. So what will happen to our second that we have drawn between A and B? It means the second now will move, will also decrease, then now will change to a tangent. It will no longer cut at 2 points, but it will cut at 1 point if we take the limit. So which means now it will then become a tangent. Just quickly indicate it. So it will be something of this kind. Yes, it will now become a tangent like that, which will cut the graph 8 points. Remember, we took a limit, so this part, this top part here does not exist anymore. It's only at this point. So it will mean now we are looking at this point specifically, which is point A. So this is a straight line. We can find a gradient at that point, but then that is the result of the limit of this equation or this expression. But then this expression is actually a formula of this point, of this form, f of prime x. Remember, this is the function f of x. So f of prime x, which means any function of which is defined by x, will be equals to the limit f of x plus h minus f of x all over h when h goes to 0. So then now this is our function that gives us the gradient at a point. So then now what does actually this mean? F prime x. F prime x simply means differentiation. This is where the differentiation part comes from, and then by first principle, which means now this limit when h approaches 0. This is by first principle. So this is differentiation. Give us a differentiation, is representation of differentiation, or a gradient of a tangent. Gradient of a tangent, or we also have what we call gradient at a point or slope. gradient or slope at a point. Or we have what we call instantaneous rate of change. In calculus, all this will actually be used interchangeably. So instantaneous just means instant, so we want a gradient at that point, not between 2 points, but at that point, which is the same as gradient at a point. Tangent, we know tangent is a straight line that cuts the graph, a curve at one point. So differentiation just simply means gradient at a point. Alright, so then now, what about the notations? Notation of differentiation. We have differentiation. We have different notation. As we can see, I've used f of x. We can have as well d of y, or dy dx, which means the derivative of y with respect to x. Or we can have what we call dy dx. So the capital D just means the derivative of y with respect to x. And then as well as we can have d of f of x with respect to x. Okay, so you can see all the symbols, they just actually mean the same thing. Okay, so or we can have a d of f of x over dx. It means we're differentiating f of x with respect to x. So here as well, we differentiate f of x with respect to x, we differentiate y with respect to x, because y is a function of x. So you need a function in order to do a differentiation. So on our next lesson, I'll be looking at examples.